There's three types of symmetry that we're going to worry about. There's x-axis symmetry, okay, which is basically like it's a reflection across the x-axis. It's like a mirror reflection, okay. If I reflect, okay, hang on, reflection across the x-axis, it's a mirror image. If you remember Math 12, the algebra behind this is replace y with negative y, right? If you change your y values, you put a negative in front of your y values, you're flipping over the x-axis, and you get the same graph, right? Does everybody see that? If I put a negative y in front of this equation, the graph flips like that, and that part flips up, but it's the exact same graph. Okay, so this has symmetry with respect to the x-axis. Okay, replace y with negative y, you get the same graph. You, we, us, them. I'll just say get the same graph. Results in the same graph, you want that? Same graph. Okay. That is x-axis symmetry. If you can change the y values by putting a negative in there and you generate the same exact graph, that's got x-axis symmetry. Okay? If there's x-axis symmetry, there must be y-axis symmetry. The simplest example of this would be a parabola. It has symmetry across the y-axis. If I flip it across like that, whoosh, I get the same graph. How do you flip across the y-axis? What do you replace? Yes. So replace the x's with negative x's. X with a negative x and which results in the same equation or graph. So if you have symmetry with respect to the y-axis, this is called an even function. Okay? So if somebody says that is an even function, it means it has y-axis symmetry. And the definition of an even function is f of x is equal to f of negative x. Okay, which is basically what we just said here. If I replace the x's with negative x's, you flip it that way. And if you get the same function, it is called even, which just means it has y-axis symmetry. So that's the test to see if a function is even, because you don't always have the graph. So, for example, we'll just do this because it's super straightforward. If I go, this is f of x. F of x is equal to x squared. F of negative x, so I'm going to test it for symmetry with respect to the y-axis. Whatever's in brackets goes in for x, right? So this gives me negative x all squared. If you square a negative, you get a, which gives me x squared, which is the same as our original function. Therefore, it's even. Okay? So if you're going to test for something to be even, you just put in negative x for all the x's. Simplify it. If you generate the same equation as you had at the beginning, it is even. If it's not even. Okay? So if there's an even function, there must be odd functions. I'll give you the definition of an odd function, and then we'll think about it in terms of symmetry. A function is odd if negative f of x is equal to f of negative x. So what kind of symmetry does that have? So we can rewrite this. All right. I'm going to move this negative over here, which is going to give me f of x is equal to negative f of negative x. Okay. What does that do, that negative there? What does it flip it over? Yeah, because it's up and down. It's changing the y values, right? So this is a flip over the x. What does that negative do? That's a flip over the y. So if you flip it over, it doesn't matter the order you go in. If you flip it this way, there's your flip over the y. Boom. All right, and then we flip it over the x. Then you flip it that way. You end up down here. Okay? This is symmetry with the origin. Okay? So an odd function is symmetry with the origin. Can anybody actually think of an example? We're not doing the trick yet. What about this? F of x is equal to x cubed. Does anybody know what that graph looks? Well, okay, let's just do the math and then we'll look at the graph. So if it's odd, then f of x, this is the same as negative f of negative x. So test it. We go negative, that's that one in front, f of negative x. So this goes in for x, like that. If you cube a negative, what do you get? You get a negative. So I get negative of negative x cubed. Negative and a negative is? So I get x cubed, which is my original function. So because it generated the original function by doing that, this is an odd function. Okay? Therefore, f of x is odd. Now, if you look at the graph, it's pretty easy to see. The graph of x cubed looks like this. So what did we do when we do this? Well, do this. We flip it over the x-axis, which does x-axis, so we're going that way. So I get this, right? That's negative, that's that, right? That's this one. And then if we do this, we flip it over the y-axis, we go that way, and you get the same graph. So that's the visual representation of it, okay? This is the algebra that proves it. This is the visual. Okay, does that make sense? So an even function is f of x is equal to negative f of x. An odd function is f of x is equal to negative f of negative x. So let's just write that down. Just to summarize, so we're good with that. Even means f of x is equal to f of negative x, and odd means f of x is equal to negative f of negative x. Now you're like, what's the point of these? These will help us later on, especially when we get into integration. If you know a function is even or odd, you don't have to do the whole thing. So for example, this isn't going to really make a lot of sense. I won't do the calculus. You don't even need to write this down. If I said, here's our function. That's not what I give you this function. I'll give you the cube function. And I said, we're going to do stuff like this later on. I want to know -2, 2. I want to know those areas, okay? Now, this is like chapter 4 stuff, right? We're not there yet. But this is an odd function, right? Does everybody see it's an odd function? It's the x cubed one we just did. I don't want to calculate the area, this area, and then add it to this area, okay? Because that's more work. That's a 0 there. You can put 0 into it, right? Into your calculation. If you can ever put 0 into your calculation, it simplifies things. So that's where we're going to use it, is when we can go, well, there's symmetry here, so I'm just going to use half of it and then multiply my answer by 2. Okay? So that we will use it to help us later on. The actual answer here is 0. This is a negative area and this is a positive area. We'll get into that in chapter 4. Okay? So it will help us later on. Here's the question I'm asking you. Is y equal to sine of x even or odd? So what do you do if it's a trig function? So you can do it graphically or you can do it algebraically. Which way do you want to do it? Algebraically? Okay, we'll do it algebraically. Okay, let's do even first. We'll test even. Testing even. If it's even, that means this. Right? That's the definition of an even function. Everybody agree with that? Okay. What's f of x? It's sine of x. So that means sine of x has to equal f of negative x sine of negative x. Pick a number. Well, okay, pick an angle, a nice angle. 90, there you go. Okay, so that means sine of 90 should equal sine of negative 90. Put that in your calculator and tell me if it's a real thing. What's sine of 90? You gotta be in degrees if you're gonna do it. What's sine of negative 90? -1. Are they equal? No. Therefore, is sine even? No. Okay, let's test if it's odd. That means f of x is equal to negative f of negative x. We can do the same angle. So we're going to get, that means sine of x is equal to negative sine of negative x, which means if we do 90, sine of 90 is equal to negative sine of negative 90. Sine of 90 is uno. We just did that. Sine of negative 90 is -1, but we have a negative in front. So we get 1 is equal to 1. So sine is an odd function. Okay? Therefore, sine of x is odd. Now, you could have saved yourself all the time instead of doing this if you remember the graphs. This is the sine graph, right? I always draw it like this, but it actually goes on in the other direction, right? Symmetry with the origin. Okay? So is cosine even or odd? Use the graph. Y is equal to cos x. Even or odd? Or neither? You could be neither. It doesn't have to be even or odd. It could just be neither. What is it? It's even, right? Because cosine graph looks like that, but you know that it actually goes in the opposite direction. So we're this way. And the definition of even is cos of x is equal to cos of negative x. And that negative x is a flip over the y-axis. If I take this part of the graph and I flip it, you're getting that, right? You're getting the exact same thing. So cosine is even. Sine is odd, cosine is even. You tell me. Yeah, it should be right. Yeah. Cos of x. Therefore, y is equal to cos of x is even. All right. Here's your homework questions. Page 8, 29 to 35, odd. It's actually like 3 questions because you're only doing the odd ones. And you just got to determine if the functions are even or odd. So it's just using those 2 definitions, okay? And then tomorrow we'll pick up, what are we doing tomorrow? I haven't decided if we're going to start limits tomorrow. We might do a couple of linear equations. No, we've done that. You know what? We're doing limits tomorrow. We're starting calculus, peoples.